And so, in my Airbnb room in Valencia, Nadisha's just popped out to get some breakfast, and I'm going to do a quick video on a tool that I've put together for IP address and subnet and CIDR block calculations. I just want to demo this tool. The reason being that I'm making it freely available to download on Dropbox, and hopefully those of you who want to sort of understand more about how IP addresses and in particular IP ranges work will find this tool useful. And I'll kind of show you an example of what I mean, and then hopefully you can download it if you're interested. This is actually going to be the first in a series of videos I'm going to do on networking, but this is not going to be a tutorial about IP addresses, what they are, why we need them. I will do further videos on that if, well, I'll do them anyway, but if you're interested and want to sort of spur me on to do that, then just leave a comment below and give me some ideas about what kind of areas you want me to focus on. But for now, this is just going to be for those of you who kind of understand IP addresses already, but would be interested in seeing a demo of a tool that kind of helps you visualize what's going on. Okay, so let's get started. So as I said, I'm kind of assuming that everybody who's watching this knows the basics, that an IP address can be split into octets, so that, or generally is represented as 4 different octets. So basically, the IP address uniquely identifies each host on the network. It's a 32-bit number, right? So in IPv4 there are approximately 4.3 billion total addresses, which is why they're rolling out IPv6. So 32 bits, and you can group them into octets here. So let's take a sample IP address here, okay, of 10.32.128.56. Okay, so that's let's say we're told that this is the IP address of a computer in our network, and let's say that we're told that it belongs to a slash, and that the CIDR notation provides a /24 on the end. So I'll just update this to 24. So let's say we're told, okay, this is the IP address of a machine on this network. First of all, can we find out based on this notation what the subnet that the IP address is, right? Because CIDR notation basically it's sort of replaces the whole sort of concept of subnet masks. Essentially, you basically, all you need to do is specify a slash and then a number on the end between 1 and 32, I guess, and you wouldn't go up to 32 all the way, but so 1 to 31, that defines how many bits are actually used to basically represent the subnet, and then the remaining of the 32 bits are used to represent the host. So every IP address, as you may know, is basically a certain number of bits are the subnet, and then the remaining bits define the host number within that subnet, right? And this that we can move that back and forth, and we can have as many bits of the subnet or host as we want, right? So let's say that we have this IP address, and we're told that the subnet is basically, it's a /24 subnet. So what that means is that out of 32 bits, 24 bits are actually used to allocate the identify the network number. Okay, so if we go to our tool over here, right? First of all, I always found it very useful to see the actual binary interpretation of the IP addresses, because when you sort of convert these binary numbers into octets and then into decimals, you sometimes kind of lose sight of sort of visually how it's working, because these numbers are actually ticking up in binary, right, one by one, and sometimes if you just sort of focus on the decimal, you sort of lose sight of the sort of incremental side of things, and the ranges, right? So you can see here that 10.32.128.56 can be represented, or is represented, in binary by the following 4 octets. So the first octet is 10, so basically you can see it's a 2 and an 8, and then the second one is a 32, which is just basically a 1 in the 32 position, etc., etc., right? So this tool, first of all, it gives you a visual, actual representation of the actual binary string, or the binary number, so you can visualize exactly what's going on. Second thing, so because we specified a /24 for the CIDR block. So CIDR stands for classless interdomain routing, and really it's kind of dispensed with the whole idea of Class A, Class B, Class C networks, and the idea is that basically we can just basically take any IP range we want, and then just with this notation /x, we can allocate an arbitrary number of bits to define what the network number is. Okay, so just for interest, this will give you what the subnet mask is. In this case, we are basically we've set all of the bits in the first 3 octets to represent the network number here, because it's /24. So 24 bits is 3 times 8, and so that's the sort of old subnet mask. But we don't really need to use that anymore. So the second question would be, well, what's the actual network number that this IP address sits on, right? 1032.128.56/24. What's the network number? What is the subnet number? And so we can basically, if we need to, look at the routing, for example, all that kind of stuff. So this here will give you the network number that this host lives within, right? And this, so what we're saying is that IP address belongs to the 10.32.128.0 network number, right? And that's basically that. So what we're saying is that all of the hosts on the same subnet as this one will also be part of this network number, right? As you may remember, the first IP address within any network range is reserved as the network number. So the hosts that you can use basically come after that, right? That sometimes there are reserved hosts as well, but generally speaking, the first IP address which is actually the network number itself, is reserved. So you can't actually have a host with that IP address, because that's the network number. So then, if we just move down, you can also see the network number here as a binary number, like this, right? So there's lots of formulas here which you don't have to worry about too much unless you're interested in playing around. But so that's the network number there, and it also tells you, okay, what's the IP address range within that network number. So it starts at 10.32.128.1, and it finishes with 10.32.128.255, right? So it's quite simple. The IP addresses, they tick all the way up from 1 to 55. So these bits all stay the same because they actually belong to the same network number. So really, what we've got is basically 255 different IP addresses, which are basically just the remaining bits of the last octet. So the first 3 octets are completely fixed, right? So up to this point, it's fixed. But then also over here, we can see it calculates from the /24 that there are 8 host bits defining the actual number of hosts on our network, which gives us a total of 256. It should be 255 if we subtract the network number. So we know there are 256 hosts on this particular subnet, 1032.128.0, and they range. And if you look at how this is where it's really useful to visualize, because all we're doing is we're basically taking. So the first IP address is taking the last 8 bits, starts from 1, and then it just fills all those 8 bits up, and then until the maximum IP address on this range is when the 8 host bits are now set to all 1, right? Which is basically your 255. Okay, so again, it can be quite useful to sort of visualize in binary, because that's the numbers are all ticking up in binary, right? So it's useful to visualize like that, I think. It'll also tell you that what's the as per the current CIDR notation, assuming that we're splitting our overall IP address space into /24 subnets, what's the next subnet? So the next subnet is 10.32.129.0. Okay, and you can see that from here. If you compare these 2 rows here, right, this one and this one, the only difference is that this one has a 1 in its least significant bit of the 16 bits used for the of the 24 bits used to define the subnet. Okay, so we just added an extra 1 there. The remaining 8 bits are just for the hosts, and they're completely irrelevant when we're talking about the network numbers. Okay, now it will also tell you what's the IP range of the next network, right? And again, it just basically starts filling up the 8 bits of the host, right, which is the last 8 bits out of 32, and it fills them up from 1 all the way up to 255, right? And then that's that. So really, that's kind of it in a nutshell. And if you're interested, I'm just going to carry on and go through a quick example here. So the example, this happened quite recently at work actually, this particular example where I'm going to change this to 23, right? So we were told at work that we've been allocated to actually set up our network in the cloud. We were allocated these private IP addresses, right? So it was basically a network, right, which was a /23 overall network, which meant now we have 9 bits for the host, and we're using 23 bits for the network number, right? So this was the range we were given, and this is how you can use this kind of tool to sort of play around a bit, right? So you can basically say, well, so we've been allocated all of the IP addresses within this subnet. So our subnet number, right? So if we take this IP address and look at what the subnet number is, so the network number is 10.32, right? So the network number is 10.32.128.0. That's the network number, and we have 512 hosts within that network that we can use. Right? Sorry about the background noise. It's a noisy Sunday morning here in Valencia. So we've got 512 hosts on the network with those 9 bits, and we can see visually in the binary how it's working. Right? So we've got we're basically it's now in the previously we were assuming that the first 24 bits were used to define the network number. Now it's actually only the first 23 bits. So everything up to the penultimate bit of that particular of these pair is used to denote the network number, and then this last bit 0 and 1 is basically that's used for the hosts, right? So we have our range goes from 10.32.128.1 here, okay, and then 1032.129.255, right? So we can see that we can see how it's filling up. So we're starting from 1, and we're filling up all the way up to these 9 bits here, just to the right of my cursor there, right? So we're actually going into the 129s there, right? And again, if you can't actually see the binary, sometimes this stuff can be a bit conceptually difficult to kind of get your head around. And then obviously the next /23 subnet is 10.32.130.0. Right? I know I'm going on a bit. To be honest, the most important thing about this video is that you actually just see the tool, you understand what it does, and then you download it and start using it. Right? So if you've lost interest by now, that's fine. But I'm just going to give you a quick example of how we split this into different subnets, right? So because we've got this entire range, right? Effectively, it means that we've been given all the IP addresses from 10.32.128.1 to 10.32.129.255, right? All those hosts, there are 512 of them. We can then split those into subnets, right? Within that overall subnet, so we can split our subnets further, and we can break it up further, right? So first of all, if we were to basically say, okay, we're going to create a 2 private subnets, right? So we're going to split this into 2 private subnets like this, and so we've basically said we're going to use a /24 notation, which means we've split our 10.32.128 subnet into 2 different subnets, right? The first of them is 10.32.128.0, and then the second one. So this is the first one, right? This is the first subnet that we, and the second one is actually 10.32.129.0, right? 10.32.129.0. But if you look at the next network from address and next network to addresses, right? So the next subnet after 128 is 129, and 129 ranges from 129.1 to 129.255. And if we go back to our original IP range that we were allocated in our overall space, that includes from 128.1 to 129.255, right? So basically, so what we're saying is if we split this /23 by using one extra bit within that IP address range to represent the two different subnets, then this network 128.0 and this one 129.0 are both within our /23 range, so we're good to go. We can actually use this. So we have two subnets. So we've gone from a position where 10.32.128.0/23, right, has been split into 10.32.128.0 and 10.32.129.0, right? So the IP addresses within this and this together form the same IP addresses that were in our overall /23 range. That's the really important point to get across. So then, we've split our /23 into two /24 subnets. But then what happened is we actually wanted to create, and these were both private, right? As in, so the characteristics of these subnets were basically identical. But then we wanted to actually create a public subnet, so a subnet with some public some public IP addresses in there as well. Don't worry too much about that side of things. Suffice to say that we wanted to basically recreate one of these subnets and split one of these down even further, right, into two subnets, right? And the way we did that was that we basically split it into, so if we take 10.32.129.0, I'm just going to write that one down up here, so 10.32.129.0/24, okay? So this was our subnet over here, right? And what we did was we said, okay, well let's split that one down into two subnets, right? So we're going to use one more bit from there to define the network number. So we're going to, just if you recall, the number of hosts, right? Number of hosts in this network, if we just go back to 24, number of hosts was 255, and number of hosts in this one was 255, right? And just to hammer the point home, the overall number of hosts, the overall number of IP addresses that we were given to begin with by our network team was 512, or well, let's say 510, right? So 510 is split up currently into one subnet with 128, one subnet with 129, and each of them with 255 addresses in. And now what we're saying is, let's take our 129.0 subnet and split it even further, right? So split that into two. So now, so this is what our new 10.32.129 subnets look like. So we have one, which is basically, so this is being split into 10.32.129.0, and then the next network number is 10.32. Again, classic example of, because normally we're kind of used to sort of network numbers beginning with zeros, and it's intuitively it's not that obvious that the subnet number, right, the next subnet number in our /23 split of the /24 parent subnet is going to start with a 128. But if you look at the binary, it makes perfect sense. Okay, so if we look here, over here, we see that the network number is this in binary, right? And we're using 25 bits. Okay, 25 bits to represent the network number. So that's basically this 8, this 8, this 8, and one more. The first bit of this last octet as well is used as a network number. Okay, so the network number is this, like this, right? And so it's basically if you look at the binary here, then the next network number is basically exactly the same, but with an extra 1 in the last bit of the network number, right, which happens to be the in the 128 position, right, of the last octet, right? So that's why I think it really makes it much easier to visualize using a tool like this, and why the network number of our second /25 subnet actually ends in 128, right? And if we look at the hosts again, so this network over here, 129.0, it starts from 129.1, right? 129.1, and goes all the way up to 129.127, and then this network, right, the next subnet goes from, if you look over here, it goes from 129.129 because 129.128 is reserved for the network number, and it goes up to 129.255. And if you remember, 129.255 was the last of the IP addresses that we were allocated by our network team in our original subnet, right? 10.32. This one, 10.32.129.255. So all we've done is we've taken all those IP addresses from 128.1 to 129.255, and we've split them into, basically, if I try and draw this a bit better now. So what we've done here is taken this original IP range that we were given of all these hosts, right, 128.1 to 129.255 in 1/23 network, and we split those that IP range, right, into three different subnets: 1/24 subnet and 2/25 subnets, right, with these network numbers and these IP ranges. But you can see the overall range is exactly the same: 10.32.128.1, right, to 10.32.129.255. Those are the same. So that's a little sort of taster, I guess, of how this tool works. A look into CIDR notation and how what the IP addresses look like when you basically allocate one more bit within your IP space to define the network number. Obviously, what you're effectively doing then is, as you add one more bit to your network number, is you're halving the number of hosts within each network. But you can really, if you're given a block, the key point is if you're given a block, a network number with a /23, then you can make as many. You can split that into /24, /25, 6, 27, 28, 29. That you can't make it /22 because then you're encroaching on an IP range that hasn't been assigned to you. But from 23 onwards, you can keep subdividing your network down. So I hope you found it useful. I will link the URL below of the actual tool. So please let me know with any comments and feedback as to if you try and download it and you can't. If you have any questions about the tool, let me know. And that's that. So if you have any ideas, about sort of network stuff that you'd like me to cover as I get started with the networking tutorial, then again, please let me know, and I will see you in the next video.